Let us now compare the work of the assistant navigator who used this table. He had to use an assumed position, abbreviated AP, for each site because he could use only integral degree values of the meridian angle, T, and the latitude, L. This necessitated using an assumed latitude of 37 north for all the sites. The assumed longitude of each site will be different because he has to assume a different longitude for each site to make the meridian angle T come out an integral degree. This is his data for plotting the same lines of position from assumed positions. He first plots all of the assumed positions along the assumed latitude line, 37 north. This is good practice when plotting a number of lines of positions. Since two of these lines must be run forward to make them 1815 loci, he uses the course 260 and plots short course lines from each of the points marked AP. This AP is for the moon site. Since the time of the moon site was 1755, he plots this AP forward along the course 20 minutes, or 5 miles, to advance it to 1815. From this advanced position, he plots the ZN 213, measures A of 19.5 miles away from the body. That point comes out on the moon line, which the navigator previously plotted from the DR position, which was exactly what we expected. For no matter from what position you compute an observation within reasonable limits, you should come out with exactly the same line of position. Now this is the AP for the Venus site. First, he runs the AP forward from 1810 to 1815, a distance of 1.2 miles. He plots the azimuth 265 and the altitude difference 5.2 toward and obtains the same Venus line as the navigator. The Sirius AP he does not have to run forward at all because the Sirius site was taken at 1815. He plots the azimuth 148 and A 17 miles away, and he has the same Sirius line as the navigator. Since all of his lines of position are the same, he gets the same 1815 fix as the navigator, which is a good check on the accuracy of the navigator's computations. To recapitulate, first, the assistant navigator plotted the assumed positions along the assumed latitude line. Then he plotted the course line through each AP. One at a time, he advanced the APs as necessary to bring them up to 1815, plotted the ZN of the body and the altitude difference, and drew in the lines of position perpendicular to the azimuth line. The center of the triangle formed by the three lines gave him this 1815 fix. It will be noted now that the fix obtained at 1815 does not agree by several miles with the DR position at 1815. Since the DR plot took no account of course and speed errors or wind and current, the DR position is presumed to be in error. It is customary to ascribe the difference between a DR position and a fix at the same time to current. The term current is a very broad one and embraces everything that has caused a discrepancy between the DR position and the fix at the same instant of time. It must be remembered that observations at sea do not always have a high degree of accuracy. Therefore, a part of what is called current may be due to errors in observation. But errors due to course, speed, wind, current, and observation are grouped together for convenience under the heading of current. The set of a current is the direction in which a current flows. That is, it is the direction from the DR position to the fix at the same instant, or this dotted line. The direction of the line is the set of the current. The drift of a current is the rate in nautical miles per hour, or knots, that the ship has been carried in the direction of the set. The drift is this distance from the 1815 DR to the 1815 fix, 11 miles divided by the time since the last fix. You will remember that the Savannah's last fix was 11:54. Therefore, the drift is 11 miles divided by 6.35 hours, which equals 1.73 knots. The majority of the components of current are variable and are liable to stoppage at any time. At sea, a navigator must consider the information available in charts and sailing directions, the state of the wind and sea, the position of the ship in known ocean or coastal currents, in deciding whether or not a current established by celestial observation will continue. It requires experience and a nice judgment to arrive at a proper decision. Suffice it to say, without something on which to base his judgment, the navigator is very apt to be wrong if he carries a current forward in his account of course and speed. Generally speaking, therefore, fixes obtained by observation should be carried forward by simple dead reckoning plotting. Earlier, it was explained that little could be learned from a single line of position except that the ship is somewhere on that line of position. Let us return now to our 0, 9, 10 plot and consider a single line of position further. It will be remembered that this sun line was computed from the 0, 9, 10 DR. Before the navigator computed and plotted the sun line, since there was no established current, the DR position was his best estimate as to the Savannah's probable position at 9:10. After plotting the line of position, however, it can be proved mathematically that this point, at the foot of the perpendicular dropped on the sun line from the DR position at the time of sight, is the most probable position of the ship for that time. This point is labeled CP, which means computed point. It makes no difference from what assumed position the line of position was computed. Suppose it had been computed and plotted from this AP. This would be the azimuth line by which the sun line was plotted. But the most probable position of the ship on the sun line would still be this point, the CP, which is obtained by dropping a perpendicular on the line of position from the DR position at the time of sight. If a current has been established and is presumed to continue, we can sometimes determine a position which is better than DR position, but is still not as good as a fix. For example, let us suppose that the current during early morning was set 025, drift 0.7 knots. Before we took the sun sight, we could have made an estimate as to the Savannah's position at 0910 by applying to the 0910 DR position the current since the last fix. To do this, we plot the set of the current just as if it were a course. Since the morning star fix was obtained at 0506, the current has been affecting the ship for 4 hours, 4 minutes, or 4.1 hours. Multiply this by the drift, 0.7 knots, and we have the distance, 2.9 miles, to plot along the set, which gives us this position labeled EP, which means estimated position. This is our best estimate as to our position before the sun sight. After we plot the sun line, we know the estimated position at 0910 must be somewhere on that line. By the same mathematical reasoning used in determining the CP, we find the estimated position on the sun line by dropping this perpendicular on that line. This point on the line, then, is the 0910 EP after the sun sight. The accuracy of an estimated position rests on the assumption that current will continue, as indicated at the time of certain observations. As previously explained, it is not always prudent to assume that a current once established will continue. Far at sea, with hundreds of fathoms under the keel of your ship, current is not of great importance. But when nearing land and in pilot waters, it may be of the most vital importance. Although it is only 1900, you will note that the navigator has plotted his DR ahead to 2000. After careful consideration of the wind, which has been blowing all afternoon from south-southwest, and if anything has freshened, and of the 0.5 of a knot set of the current toward 046, indicated on the pilot chart, the navigator has decided that his current will continue in some degree. Having no better information, he uses that determined by the 1815 fix. Set 042, drift 1.7 knots. Plotting that current from the 2000 DR, he obtains his 2000 EP. In approaching pilot waters, the careful navigator finds it advisable to determine these two positions, the EP allowing for current and other information short of a fix, and his DR. In laying a course past dangers, he carefully considers both positions. Having decided that the current will probably continue, he wishes to compute what course he will make good if he continues to steer 260 true. Let us consider his ship at 2000 DR. If the captain stopped the engines, in 1 hour the ship would drift with the established current in the direction of the set for 1.7 miles, but the ship's engines are not stopped. All the time, the ship is steaming through the water at a speed of 15 knots on course 260. In an hour, then, it will drift here, and at the same time steam on course 260 to this position. This is the final position. Therefore, the course made good in 1 hour is along this line, or course 265, and the speed is this distance, or 13.5 knots. The Savannah is approaching land and will make a landfall off Cape Henry before morning. The navigator, therefore, transfers his 2000 estimated position from this plotting sheet to the coastal approach chart. Note how carefully he checks the transfer of his 2000 position to the chart. A disastrous mistake might be made at this point if he carelessly plotted the position in error.